Hi class. This was supposed to be our agenda today. I am so sorry that I wasn't able to be there. I was very sick all morning long. So I'm really sorry to have missed class. My plan is to record these videos in chunks just so that they're not so long and so you can pick and choose what you want to pay attention to. So we are gonna kind of chunk our class just like what we would in person. So this recording is going to be this first kind of section here of substituting solutions, types of solutions, and then graphing. Then I will make a second video of this section, which is solving systems algebraically. And then the last section will be inequalities. So you can expect to see 3 different videos, and you can pick and choose which ones you want to watch, or maybe you'll watch all of them, which I would recommend since we didn't have class. But we're going to get started. So first thing, there are 3 types of solutions to linear systems of equations. All a system is we're saying, okay, we have 2 equations for 2 lines. So you can see in this first picture, this is an equation, which is the blue line. This is an equation, which is graphed and is the red line. A solution is where the lines intersect or where they cross. So in this case, the solution is located at 2, 1, x, y. That just is where they cross. That's all that is. It's the point where they intersect. Typically, when we're looking for one solution in the real world, we're comparing 2 different kinds of plans. So it might be a phone plan or gym memberships. And the point of intersection is where they both cost the same in like a real world experience. So that's what a solution looks like. It's an intersection on a graph. It's an ordered pair, it's x, y. A shortcut that is helpful to know if there's going to be a solution or an intersection point is they have different slopes. We've talked about this before, we're gonna review it more today, but as you know, this invisible spot here, there's a slope of 1, whereas here the slope is 2. So different slopes, they will eventually cross. In the middle, we have a different type. So in the middle, we have what's called no solution. We're here. No solution, parallel lines. Why is it called no solution? Because there is no solution or no point at which the 2 lines will cross. When they're parallel, that means they're never going to run into each other. And this happens because they have the same slopes. They have the same slopes, but different y-intercepts. So we can see the y-intercept for the blue line is at 3. The y-intercept for the red line is at 1. So they're always going to run next to each other. They're going to go in the same direction, but they're never going to actually cross because they have the same slope of 1. So same slope, they're never going to cross, no solution. Then the last case is where everything is the same. Again, this is something that we've talked about before. We have talked about when there's infinite solutions. Some people call this a consistent system, right? Which one solution is also a consistent system, whereas no solution is inconsistent. That might come up in your homework, but one solution, no solution, and infinitely many is the most common. And all that means is that when you graph the lines, they overlap so that it looks like there's only one line. Even if you graphed 2 different equations, they end up overlapping. It's one single line. They have the same slope and the same y-intercept because they're completely on top of each other. So these are kind of our 3 scenarios. We're going to practice graphing them soon so that you'll be able to see yourself what they look like based on different equations and how we can even graph these lines. But first, part of your homework is also being able to determine if a given point is a solution if you don't graph them. So I'm going to walk us through this second point first, and then we'll come back and talk about A, because A is this one. So our second point is 0, -5. How do I test to know if a point is a solution when I'm given 2 linear equations? We just use substitution. We've used and heard this word before. It just means replace. We were using this in our very, very beginning class when we replace the variables with the numbers that were given. So we have x is 0, and then we have y is 5. So x0, y is -5. I'm going to take this first equation and bring it over and see if it's a solution. So I've got 3x minus y equals 5. I'm going to replace the variables with the numbers we were given. That's all I'm doing. But they asked us to test this point, so we're going to test the point. So we've got 3 times 0, because that's what x is, minus y, which is -5, equals 5. Okay, so first thing I'm going to look at is 3 times 0, which is 0. Now, we have long talked about this in class. This is a tricky one when we have this double negative here. 2 negatives together like that turns into a positive. Then I add 0 plus 5 to get 5. Does 5 equal 5? Yes. Okay, so that means it's a solution, or it's a point to that first equation. It's on that line. Now I have to check my second equation. So I bring my second equation over, which was x plus 2y equals 11. So using the same substitution strategy, I'm going to replace y with -5, and I'm going to replace x with 0. So let's try that out. I've got 0 plus 2 times -5 equals 11. 0 hasn't had anything happen yet. It's still here, my x, plus 2 times -5 is -10 equals 11. 0 plus -10 is -10 equals 11. This is not true. So this is not a solution. So 0, -5 is not a solution because it works for the first equation, but it doesn't work for the second equation. So what we have to do then is try the other point that they gave us, which is over here. I circled in orange, this 3, 4. I already have this solved out for you for saving time. I just wanted you to see step by step what happens. So same thing happened over here, replacing x with 3, and then replacing y with 4. Going through each step, we get 5 equals 5. That works for the first equation. Repeating again for the second equation, and 11 equals 11. Again, using that same substitution. I'm just for the sake of time not working through each step, but then you would say, yes, 3, 4 is a solution, meaning that is the point at which those two lines would cross when they're graphed. So here was a problem set for you all to practice and to try. I would recommend if you're watching this video on your own time, this would be a good time to try it on your own and to practice. I would pause the video, see how you do with substitution, and see if you can figure out if the ordered pairs are solutions. So if you're going to pause it to try it on your own, pause it now. Okay, I'm going to show how we get the solution. So starting with this first equation, 2x minus y equals 4. I am going to replace x with 2, because that's what I have, and y with 0. Everything else stays the same. So 2 times 2 minus 0 equals 4. Well, 2 times 2 is 4, minus 0 equals 4. 4 minus 0 is 4, so that's great. It's a solution for the first equation, but I'm not done because I have to check both equations. So now I have to try it with the next equation. Because remember, we have to imagine these are graphed lines. If we were to graph them, would the point be on both? So now we have 3x plus 4y equals 6. Okay, so again, I'm going to replace x with 2 and y with 0. Everything else stays the same. So 3 times 2 plus 4 times 0 equals 6. 3 times 2 is 6, plus 4 times 0 is 0, and then equals 6. 6 plus 0 is 6. 6 equals 6. Yay! So, okay, so it works for both. So this is a solution. That is true. This is where those two lines would cross. Now let's try the next one. So again, I'm going to take the first equation and start substituting. So it's x minus 5y equals 12. I'm going to replace x with negative 8, because this is x, this is y. Minus 5 times y equals 12. Y is negative 4. So from here, negative 8 equals, or not equals, whoops. I should have negative 8, and then negative 5 times negative 4 gives me a positive 20 equals 12. Negative 8 plus 20 is 12. Does 12 equal 12? Yes. Okay, so it's a solution to the first one. But just like last time, I have to check, does it also work for the second one? Now I'm going to try with the second equation. So now I have y equals negative 3x plus 7. Now notice this is in slope-intercept form. We're going to be using those three forms again, how last time we learned about standard form, point slope, slope-intercept form. We're going to really be trying to focus on getting our equations from standard form to slope-intercept form today to graph. So we're going to hopefully be working with these kinds of equations more often. But no matter what format, I can substitute the same way. So I'm going to replace y with negative 4, and I'm going to replace x with negative 8. So negative 4 equals negative 3 times negative 8 plus 7. Negative 3 times negative 8, we know a negative times a negative is always a positive. So I've got negative 4 equals 24 plus 7. 24 plus 7 is 31. Negative 4 does not equal 31. So this is not a solution. Your homework will give you yes or no's. Like they'll just give you a point in equations and ask you if it's a solution or not. Sometimes it'll say true or false. It'll say this is a solution, true or false. Either way, you're going to be using your substitution skills to test them. And then either it does work for both, like letter A, or it doesn't work for both, like letter B. I'm going to skip letter C at this time. If you want that solution, send me an email. If you want to chat about it, let me know. But this is just to give you more examples of what this looks like. Okay. Again, we have another one to test out. This is more of the format of what's going to be on your homework. It'll say, does the ordered pair satisfy the system of equations? Yes or no. The steps are still the same. So for example, I have 2x minus 3y equals negative 9. Again, if you're going to test yourself, which I recommend, this would be a good time to pause. So we've got 2 times 3, because that's x, minus 3 times y, which is 5, equals negative 9. 2 times 3 is 6, minus 15 equals negative 9. 6 minus 15, this is putting us in the negatives. These are those scenarios where we don't have enough money or we're still owing people money. We're at negative 9 equals negative 9. So that's great. It works for the first equation. But we also have to test the second equation, which is 4x plus 2y equals negative 2. Because in order for it to satisfy the system, it has to work for both equations. All right, they both have to be a yes. So, oops, I have 4 times x, which is 3, plus 2 times y, which is 5, equals -2. So let's see if this works. So 4 times 3 is 12. Then I have 2 times 5, which is 10. 12 plus 10 is 22, which does not equal -2. So this would be no. I would say no, this does not satisfy the system of equations because while that point is a solution to the first line, it is not to the second line. That's not a true statement, so it's not on that line. Okay, moving back to our graphs, we saw these at the beginning of this lesson. We're going to keep using these. Our goal is to make some graphs that look like this. Probably like this, where we're not really going to make the infinitely many solutions graphs, but we're probably going to be making these first two. I just really want to highlight that even before you graph anything, you can know the type of solution. If the slopes are different, remember, if this is y equals mx plus b, m always is our slope. If that number in front of x is different, there's going to be one solution. However, if we have y equals mx plus b, and the m, or the slope, is the same, then it could either be no solution or infinitely many, because they have this in common. However, in a no solution scenario, they have different y-intercepts. Our y-intercept is always the b. That's the number that's on the end. So for example, in this picture here, they have different y-intercepts because we have 3 and 1, which we can see on the graph at 1 and 3. But their slopes are the same. They both have a slope of 1. So to test that, we can visually compare equations. So without even graphing them, I can tell you how many solutions they have. So I like to use slope-intercept form to help me because that's the most obvious. Here's my slope at m. Here's my y-intercept at b. Right, this is the y-intercept. And then m is always my slope. So I'm going to look for equations that are already in that form. And I see these two here. These are going to be my easiest to look at first. So if I look at this first example here, I see, I'm going to highlight my slopes. They have the same slope. So m, oops, you can't see that. M is same. Right? That's our slope. So that means it's either infinite solutions or no solutions. So it cannot be one solution. That's not possible because they need different slopes to have one solution. The next thing I'm checking is I'm checking the y-intercept. Now, my y-intercept is always on the end. I have a -5 or -5, and I have a +5. So they are different. So B, or my y-intercept, is different. When that happens, they're going to be parallel. So these are parallel lines. They're not going to cross. Parallel lines have no solution. That means they're going to go side by side. If I drew a picture, we could imagine them going like this. But they're never going to cross. Let's take a look at the example on the bottom. So on the bottom, I'm going to do the same thing. I'm going to look at my slopes first. I have a slope of 2 because it's in front of x, and a slope of -3, which is in front of x. I have different slopes. When the slopes are different, so different slope, or m, that always is the same answer. That is always one solution. That means they are going to cross somewhere eventually. We don't know where yet without graphing or solving algebraically, but we do know that they're going to cross. So we can cross out no solution and infinitely many. It's not those. This is a one solution, which I'll color this in nice and blue so it's clear. And this is a no solution. Now, these equations on the top don't look like the form I normally like. They look different, but we can still use the same strategy. So, first up, we worked on this last week. This is in standard form. This was in your homework from last week. This is that ax plus by equals c form. We joked that it's not very standard, so we're going to switch to slope-intercept form. So if I have 2x plus y equals 4, I'm going to move the 2x over so that y is by itself. Now I have y equals that negative 2x. And then since 4 doesn't have any symbols around it, I know it's positive. This is good news. It's now back into my slope-intercept form that's up here. And I can identify my slope and my y-intercept. So I'm going to highlight them now. So here's my slope and my y-intercept. Now, second equation, also in standard form. I'm going to have to fix this one. So I've got negative 4x minus 2y equals negative 8. I'm going to start by moving x over just like last time. The opposite of a negative 4x is a positive 4x, positive 4x. So negative 2y is still over here. It did not move. It's just coming down. Then I have 4x minus 8. Now, this is close to my slope-intercept form. It's almost what I'm looking for, but in order to be in slope-intercept form, y needs to be by itself. Right now, y is paired with that negative 2, so we have one more step. We have to divide everything by negative 2. Again, this is a skill we did last week, so if this is something where you're like, uh-oh, I would take a look at your notes from last week to have some reminders. There's also some more problems in this lesson that this will come up, but just in case, there's more options for you to see this, so don't worry yet. So I've got y equals 4 divided by negative 2 is negative 2, and negative 8 divided by negative 2 is positive 4, because a negative divided by a negative is a positive. So I've got a slope of negative 2, and my y-intercept is positive 4. So going back to those rules that we had, since my slopes are the same slope, it can't be one solution. Not possible. Oops, that's the wrong box. Sorry about that. Let me clean that up. Okay, so it can't be one solution. It either is no solution or infinitely many. So we know at least that they're parallel because their slopes are the same. The next thing I ask myself is, well, what about the y-intercepts? In this case, the y-intercepts are also the same. They have the same slope and the same y-intercept. Since they are both the same, that means they're the same line. They're right on top of each other. They're going to overlap. That is infinitely many solutions. They're going to be on top of each other when we graph them, just like what was in those pictures. So infinitely many solutions. Lastly, this came up at the end of our class last week. So just bringing it back, when we have equations where it's just x equals a number and y equals a number, these are vertical and horizontal lines. So x equals 1 is going to be a vertical line. If this is my graph like this, if this is 1, this line is going to come all the way straight through like this at 1. Whereas y equals 4 is a horizontal line. If this is where y is 4, it's going to go across like this. In this case, whenever we have two equations that are solved for a single variable and a number, there's always going to be one solution. There's going to be one point where they cross, as long as you have x and y, and you have two different variables here. So this is an example that's rare, but does come up sometimes. This is an example of one solution. There's going to be one point where those two lines cross. They just happen to be vertical and horizontal rather than parallel rather than different slopes. So they're just going to cross at one point. Parallel lines never cross. They always cross when the slopes are different or if you have a vertical and a horizontal. Okay. This is our major goal for today's lesson, is to be able to graph lines to identify the solution. Again, reminder, solution just is x, y. It's the point where they cross. Now, your homework definitely is going to have you graph multiple lines. It will be a little bit easier because you're going to be using digital tools. However, the process of graphing the lines is exactly the same. So let's start with, how do we do this? Okay, good news. My equations are in slope, intercept form. I'm really happy about that because those are the easiest lines to graph. We're going to start with this first one here. This is my y-intercept. This is my slope. So if you remember from last week when we were making these equations, we were given the slope, we were given the y-intercept, or we were given 2 points, and we were making these equations ourselves. We're going to kind of go backwards. You're now given the equation, and you're going to make the line. So my y-intercept in this case is located at 0, 3. That's what this 3 tells me. So I'm going to put a point on my graph at 3. That's my first point for this first line. Next is my slope. Friendly reminder, all whole numbers are written as over 1. So we've got 4 over 1. This is our rise. This is our run. Again, this is a review. We're building off of those skills from last week. Now, this tells me up 4 and then right 1. Problem on this graph, if I start at 3 and I go up 1, 2, 3, 4, over 1, I'm kind of off the graph. I can estimate it's around here. The other option is to work my way backwards. If I can go up 4 and 1 to the right, then I can go down 4 and 1 to the left. So the alternative to make this line is go down 1, 2, 3, 4, over 1. There's another point. I'm going to do it again. 1, 2, 3, 4, over to the left 1. Now I have a line. Well, I have a point. I have points to make my line. Here it is. So this is the first line, which is y equals 4x plus 3. Now I'm going to do it all over again, but for the second line. So in my second line, this is my y-intercept, right? It's the b. It's at 0, -2. I'm going to put an orange point there. Next, I have my slope. That's m. Now, it seems invisible, right? This is those ghost ones that we talk about that are in front of all of our variables, that we don't write it unless we need to. So in this case, my slope is -1. We could think of this as -1 over 1. So on my graph, this means I'm going to go down 1, right 1. So instead of my graph increasing, this is a negative slope, so it's going to be decreasing. So I'm going to go down 1 and then right 1. Down 1, right 1. Down 1, right 1. So you can see my graph is starting to go this direction. It's going down, unlike my red line. But I can keep it going in the other direction by moving up and then to the left. So I can go up, left, up, left, up, left, up, left to create this line. So now I have my second line, which is at y equals -x minus 2. Now, these lines do cross, and I can see the solution. This is where they overlap, this point here in the middle. which is at -1, comma, -1. This is the solution. So when you're graphing a system and you're looking for a solution, you're looking for where the two lines intersect or where they cross. So this is where our lines intersect or cross, is at -1, -1. Now we're going to do it again. So there's going to be lots of examples, and I highly recommend that you practice these as well before attempting to do your homework, especially with positive and negative slopes. The negative slopes can be kind of tricky to know what direction you're moving. So let's try another one. Take a look at these. Okay, so same thing. I'm going to take a look at this first line. I've got a y-intercept at 2 because this is our slope-intercept form. So this is at 0, 2. I always start at my y-intercept. So I put my first point at 2. The next thing is I see my slope is -2. Again, all whole numbers are over 1. So I've got -2 over 1. That tells us our direction. Rise, run. We can think of this as down 2 and then moving to the right 1. So from my y-intercept, I'm going to go down 1, 2, right 1. 1, 2, right 1. And I'm going to keep repeating that pattern. Now I've kind of run out of space in this direction, so I can reverse it the other way. If I go up 2, then I have to go left 1. So I can continue my line. So this is y equals -2x plus 2. Now, same thing, but for this next line. I have a y-intercept at -2. 0, -2 is my y-intercept. Put my point here at -2. Now, next step, slope. So this process is always going to be the same. Here's my slope. It's -2 over 1. Notice something here. I have the same slope. So even if I don't finish graphing, I should still know about the solution. Keep that in your mind while we continue to graph. This means down 2, right 1. So I'm going to go down 1, 2, right 1. I run out of room, so I can go reverse. I go up 1, 2, left 1. 1, 2, left 1. 1, 2, left 1. Here's my line. Y equals -2x minus 2. Now if I use my eraser tool to get rid of these little sketchy lines that I use to help us see how we get to each of these points, it'll be a little less crowded. What do you notice about these lines? The orange and the red line, what do you notice? Hopefully you notice that these lines are parallel. Parallel, that means they will never cross or intersect, which means there is no solution. No solution. This is super, super important because there are going to be times when you will be asked to graph and then talk about what type of solution it is, whether it's one, none, or infinitely many. If you have parallel lines, there will be no solution. They're never going to cross because they're parallel. They always have the same slope, but different y-intercepts, which we can see here in this example. Okay. Next one. Try this one. Take a pause. Don't immediately watch what I do. Try it on your own and see if you can graph it. Okay, if you paused and you did it, I hope you did. If not, here's the answer. So I get this question a lot. People see these kinds of equations, they go, whoa, where do I start? There's no b. If there is no plus b, right, if that's gone, that means you're starting at the origin at 0, 0, right, because there's no number. This is the same as saying plus 0. So we are going to start at 0, 0 here in the center. And then our slope is already in a fraction form, which is really convenient. That's really nice. If I have negative 2/3, that means down 2, right 3. So I'm going to go down 2, 1, 2, and then right 1, 2, 3. I can go down 1, 2, right 1, 2, 3. I kind of end up off the graph, right? So we got to reverse it. We got to go the other way. I'm going to go up 1, 2, and then go left 1, 2, 3. Here's my line. This is y equals negative 2/3 x. And I'm going to get rid of these extra lines that I drew to help me graph. Whoops. Okay, next, I've got this line here. Here's my y-intercept at 0, 5. This is my y-intercept. I'm going to put a point at positive 5. It's all the way up here at the top. Now, again, I've got this invisible slope here. There's that ghost one. So 1 over 1, so my rise over my run. We can think of this as up and right. Right? Up 1, right 1. If I go up 1 and right 1, I'm off the graph. So I'm going to reverse, and I'm going to go down 1, left 1, right? Because the opposite would be down and left. So down, left, down, left, down, left, down, left. Here's what my graph looks like over here. This is y equals x plus 5. This does have one solution. It's here. Being able to write this as an ordered pair as x comma y is super important. This would be a time to make sure that you can indeed write that ordered pair. Since x always comes first, it's negative 3, comma, positive 2. Even if I hadn't graphed, I would have known that this has one solution because they have different slopes, and whenever there's different slopes, they will intersect or cross eventually. All right, let's keep going. I'm going to keep just going through and putting the answers on here. You will be able to pause as you need to, but this is just so that you have examples to see what these look like. So again, y-intercept is at negative 4. My slope is 2 or 2 over 1. So I'm going to go up 2 and over 1, up 2, over 1, up 2, over 1, up 2, over 1. I've got my line for y equals 2x minus 4. Then I'm going to go the other way. So I've got this other equation here starting at positive 1. So 0, 1 is my y-intercept. I'm going to put my point here. Then my slope is 1/3. So that means up 1, right 3. Up 1, right 1, 2, 3. Up 1, 1, 2, 3. I kind of go off the graph. I can reverse. Down 1, left 1, 2, 3. Down 1, left 1, 2, 3. Again, kind of off the graph. This is y equals 1/3 x plus 1. So this is another example where there's one solution. They have different slopes, so I know that, and they intersect at 3, 2. That's our solution right here, is where they cross. All right. Now, in this case, you're matching the equation of the line. So we've got line S and line T. They already graphed them for you. That was very nice of them. And you're just deciding which one of these graphs shows the lines and their solution. So just like if you were graphing it yourself, you're going to check for the y-intercepts. The y-intercept should be at negative 3 and positive 5. All of these graphs have intercepts at negative 3 and positive 5, so that's not really going to help us. We are going to use the slopes. So from -3, I need a slope of 1/3. That's up 1 over 3. Now, graph A shows up 1 over 1, 2, 3 to make these points. And it does have a negative slope of 1, right? Down 1 over 1, down 1 over 1, down 1 over 1. But look at where they put the solution. They said that P is over here. That is not the solution, because it's not where the lines cross, right? The solution is here, so it can't be A. Next, I know that B isn't it because that's not how our graph is supposed to look, because letter A is how our graph is supposed to look. So these slopes are incorrect. So if we take a look at this one, this is a slope of 1, 2, 3 over 1. This is showing a slope of 3 over 1, not 1 over 3, which is why that one's wrong. It is actually letter C, because it looks just like letter A, except for they correctly identified that the solution, letter P, is where the two lines intersect, which in this case is at 6, -1. Of course, it can't always be that easy. Sometimes we're asked to graph equations and they're not given to us in slope-intercept form already. That kind of came up a little bit earlier when we were comparing the equations in that table. This will happen in your homework. There are going to be multiple instances when they're going to give you two equations, usually in standard form, at least one of them, and they're going to ask you to graph them. Now, standard form is helpful for some things, but it's not helpful for graphing because it doesn't tell us the slope or the y-intercept, which we need to graph. So we need to change them to slope-intercept form, which we were practicing last week. We are pros at this. I believe in all of you. You've got this. So this is when we're trying to get back to y equals mx plus b so that we have all of our information in order to graph. I would recommend pausing and trying this yourself. Here are the answers. So we're going to get y alone. We add x to both sides. Now I have 4y equals x plus 4. Then we have to get rid of 4, so we divide, divide, divide. We have y equals, and then this is what I see a lot. But what happens here? What do we do with this x over 4? We talked about this briefly in our lesson last week, but as a reminder, just like how there's an invisible 1 in front of x, we can pull these and treat them like it's its own fraction. We can keep 1 and 4 together like partners so that we have 1/4 x. So then our slope is 1/4 and our y-intercept, or our b, is 1. So this is an equation that we know how to graph now. Similar, we'll look at this other example. I'm going to take away 2x. Take away 2x. I have -2y equals -2x minus 6. Notice that this negative is staying with this 2. It didn't move, it didn't go anywhere, it's still there. My last step is I want to get y alone, so I divide everything by that coefficient, by that -2. Y equals x. And then -6 divided by -2 is a +3. Here's my new equation. Again, I can graph this because it's in slope-intercept form. So my y-intercept is at 3. And then my invisible slope here is actually a slope of 1. Right, that's my slope. Okay, so tying it all together, we need to rewrite one of these equations before we can graph, which is going to be the equation that's in standard form, which is this one. If I have x plus y equals 4, I'm going to just fix it by taking away the x on both sides. So I have y equals -x plus 4. This way, I now have it in slope-intercept form. So I start at +4. My slope is -1/1. So down 1, back 1, right? You can imagine down 1, back 1. Oops, I'm going the wrong direction. Notice if I go the wrong way, I now have a positive slope. This is going to happen to all of you. It just happened to me. So, got to back it up. That's the wrong direction because I need a negative slope. So, positive 4, down 1, then to the right 1. Down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. There we go. Okay. So there's my not so straight line. Y equals negative x plus 4. And then this goes back again to that table we talked about when we reviewed y equals 1. So y equals 1 here, and 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 everywhere in between. This is a horizontal line. So then our point of intersection is at 3, 1. So our solution is at 3, 1. Let's try the next one. Now, this one, take a look at your equations. Our first equation is already in slope-intercept form. Oh, excuse me. Slope-intercept form. That's good news for me. I can graph it as it is. Then I have standard form. So I can't graph that as it is. I'm going to have to change it to slope-intercept form in order to be able to graph it. To do that, I'm going to take away 4x on both sides so that I have y equals negative 4x minus 1. Now I'm able to graph both. So let's graph the orange line first. My first point is at negative 3. Then my slope is negative 2. So that means down 2 and then right 1. So if I go down 1, 2, I go right 1. Kind of running out of space already, so I'm going to do the reverse. I'm going to go up 2 and left 1, up 2, left 1, up 2, left 1, up 2, left 1. Now it's time to graph the second line, because that's only one. I'm looking for where they cross or where they intersect in order to find the solution. So my y-intercept is at 0, negative 1. Here's my first point. My next step is to use my slope. In this case, slope is still m. It's the number in front of x. It's negative 4 over 1. So I'm going to go down 1, 2, 3, 4, and over 1. Looks like we have the solution already. Let's keep going. Up 1, 2, 3, 4, back 1, 1, 2, 3, 4, back 1. We're kind of going off the graph. So our lines intersect, or they cross all the way down here at the bottom. This is our solution. So our solution is at 1, negative 5. I hope this is helping. I hope this is nice to have some extra examples other than the videos in your homework. Please do, if you're watching some of this stuff and you're like, whoa, I need her to explain that more, send me an email. I'm happy to meet you for office hours. Now, this is going to be more standard for your homework. In this case, both of these equations are in standard form. Both are in standard form, so we have to fix both of them. So minus 2x minus 2x. I have y equals negative 2x plus 2. On the other hand, I'm going to add x for this equation so that I have y equals x minus 4. Here are my two equations. They have different slopes and y-intercepts, so I'm going to find out where they cross to find their solution. I'm going to make this equation the orange equation. My first point is at 2. Then I'm going to use my slope of negative 2, right, because this is slope, down 2, right 1, down 2, right 1, down 2, right 1. I can do the reverse and go up 2, left 1. Then I can go the other direction. Right? I have my full line. Now let's switch. I'll make it red actually. Make this line red. This is where we start at that y-intercept at 0, -4. Here I am, down here at -4. That invisible slope, the one we can't see, is just 1 or 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, all the way across. My solution is here, which is at 2, -2, because that's where they cross. There's another practice problem for you to do. It's the same kind of thing. You're going to change to from standard form to slope intercept and graph. For the sake of the length of this video, I'm not going to do that. This is going to come up in your homework. I purposely screenshotted this to help you all. There are going to be times when you're graphing and the lines are going to be parallel, or they're going to be overlapping. When that happens, the parallel lines that have no solution, you're just going to select no solution. However, if you find that there are infinite solutions or they're the same line, the ordered pair is just x comma the y part of the equation. This doesn't make sense, so let me show you why. If I change this to slope intercept form, because it's not right now. Right now, it's y minus 2x equals 5. If I move 2x over, it's now y equals 2x plus 5. If I change this next equation, so the second one, I'm going to subtract 6x. We've done this before. Then I'm going to divide everything by -3. And I'm going to get y equals 2x plus 5. So notice these are the same equation, which is why it is infinitely many solutions. Okay, you would be able to change them. This is just like those questions that were in the table at the beginning of class and see, oh, they're actually the exact same equation when I go to graph them. So the solution then is, solutions are always x comma y, right? So we still have x, but y, instead of having y here, they're putting what y is equal to. Y is equal to 2x plus 5. We see that in both equations because that is where it would land on the graph if you were to solve it algebraically. So just know this can be a little confusing. I didn't want you all to be thrown off. All you're saying is that the solutions are always the same because it's somewhere on the line. This is an infinite solutions situation because once you change the format of these lines, they are the same. We can see that here. So it's just x comma the part of the equation that comes after y because that's telling us what y is equal to. Then this would be a break for class. So this is going to be a break in the video. Hope this is helpful. And look out for the next video.